Hello everybody and welcome to your Unit 1, Lesson 3. So today we are going to be continuing with our astronomy unit and we're going to be taking a look at how the Earth actually moves on its axis. Because we're going to discover today that the Earth doesn't have perfect movement. It doesn't spin smoothly on its axis. And we're also going to find out some misconceptions that we have about how the Earth revolves around the sun and how the moon revolves around the Earth. So before we get started, just make sure that you've gone into your Lesson 1 or your Unit 1 Lesson 3 should be labeled with today's date, which is August 24th, 2020. Underneath your warm-up section, there should be a link to download your interactive notebook pages for today, and that is where your guided notes are. So those notes go with this presentation. So don't watch this until you have your notes downloaded in your Google Drive. But if you have them and you're ready to go, we can go ahead and get started. I will say that this lesson is a little bit more difficult than what we've done so far. So if you have any questions or you want to schedule a time to meet with me one-on-one for tutoring, I do have office hours in the afternoons from 3 to 4 p.m. So just send me an email and let me know if you want to meet to go over this a little bit more in depth. And I will say also there are videos that are linked in this presentation. The slides are available on Canvas. I strongly recommend going into this presentation, pulling up the actual PowerPoint and watching those videos, okay? If you're watching this, it means that you've missed the live Zoom session that we're having. So where I kind of show the videos myself and go over everything. So definitely go back and watch the videos here because it will help you a lot with explanation. Okay, so let's go ahead and get started. So for your warm-up today, we watched the wobble video, so the dance, the wobble. I'm pretty sure a lot of you know how to do that dance. It's really popular at weddings. And it's a really catchy song too. But for your warm-up, we were just talking about what do you think that video and that dance has to do with the Earth and the way that the Earth moves in space. Well, what we're going to find out today is that the Earth doesn't spin smoothly on its axis. It actually wobbles a little bit. Okay, so it wobbles back and forth and the tilt of the axis of the Earth changes a little bit, and we're going to talk about that today. So before we get into the actual movement of the Earth, we have to talk about something called a barycenter. Okay, and this is the point between two objects where they balance each other. Okay, when we talk about celestial bodies, so when I say a celestial body, I mean a sun, a star, well, the sun is a star, but sun, star, planet, moon, asteroid, a celestial body is just an object in space, okay? And if you have two bodies that are equal in mass, meaning they have the same amount of matter in them, you've got two bodies that are equal in mass, their barycenter or their center of gravity will be in the middle. However, it rarely works out that two objects in space that revolve around each other are the same mass. Typically, one is larger. So when we think about our sun and our Earth going around the sun is definitely larger than our Earth, so much larger. And then when we think about our moon revolving around the Earth is larger than the moon. So the center of mass, where two or more celestial bodies orbit each other, is the barycenter, okay? So typically when we talk about the Earth revolving around the sun or the moon revolving around the Earth, we just say, oh yeah, the moon revolves around the Earth. But that's actually not exactly true. So when a moon orbits a planet or a planet orbits a star, both bodies are actually orbiting around a point that lies outside the center of the larger body. So what does that mean? That means, let's take the example of the Earth orbiting around, or the sun, sorry. Let's take the example of the moon orbiting around the Earth, okay? So we can say, oh yeah, the moon orbits the Earth, but in actuality, because the Earth is larger, there's a center of gravity there. There's a point right outside the Earth where the center of gravity is, and the Earth revolves around that spot, and the moon also revolves around that point. Okay? So the Earth doesn't just sit still. So the Earth does this teeny tiny little orbit around the center of gravity, and then that moon is also circling around the center of gravity, which causes it to circle around the Earth itself. Okay? And there is a video here of a demonstration of barycenters that I highly suggest you go into the presentation and watch. So does the sun stay still? And the answer is no. So the sun is not stationary in our solar system. And the word stationary just means still. Okay, so the sun does not actually stay still in the universe, right, in our solar system. So the sun actually moves as the planets tug on it, causing it to orbit the solar system's barycenter, okay? And the solar system's barycenter lies right outside of the sun, okay? Because that's where most of the mass of the solar system lies, is right outside the sun, okay? So the sun does this teeny tiny little rotation around the center of mass, and then all of the other planets also orbit that, which cause it to orbit the sun itself, okay? The sun never strays too far away from the solar system barycenter, okay? So it doesn't move enough to really cause a huge difference or cause any issues, but it does do its own orbit around the center of gravity. And again, there is a YouTube video here that is linked that I highly suggest you watch. So the two main things we're talking about today are precession and nutation. So let's go ahead and get into precession first. So a precession is a change in the direction of the axis of the Earth, but without any change in the tilt. So what does that mean? So if we take a look at this picture right here, we see the Earth that's spinning like a top, okay, like a toy top. So if you spin a top and you leave it alone, it just kind of goes in a perfect spinning circle, right? And then the top of it stays straight up. But if you were to flick the side of it, it would kind of wobble to the side and it would go in this sweeping motion, okay? This is similar to a precession. So remember, our Earth is not straight up and down in our universe. It tilts on its side. So as it spins, the location of the actual tilt will change, okay? So over time, and it takes a really long time, a precession will occur where our actual axis will rotate around like a top that's been knocked on its side, okay? So what does this mean? What does a precession even do in terms of our Earth? Well, it will change how we look up at the stars, or it will change the stars that we are able to see and their position in the night sky, okay? So it changes the stars near or not near the pole, but it does not affect the seasons, okay? So it's not something that's going to change the seasons of the Earth. It really only changes the stars that are near the poles, okay? So the North Pole, South Pole. Currently, the Earth's axis points at Polaris as the northern star, but it won't always be that way, okay? So let's say that this is now 2020, and our axis is pointing up this way, and right now it's pointing true north, and the North Star is going to be Polaris, and that's just the name of the star. But over time, as this precession occurs, and this axis moves in our solar system, the position of the stars will change, and we will get a new North Star. And there's about 4 North Stars or 4 stars in the solar system that could be our North Star, depending on where we are in this precession. So if we look down here, each gyration or each precession takes around 26,000 years. Okay, so it takes about 26,000 years to do one full gyration of a precession. Okay, so it's a long time. This is something that is a very gradual, and we would not be alive to see the changing really of the North Star. And again, here is a YouTube video that I highly recommend you watch. If you were in the Zoom meeting today, we should have watched it together in class. And here is an animation for you to see. So if this, imagine that this is called a gyroscope right here, but imagine this is the Earth, and then the axis, so the poles sticking up at both ends, is the axis of Earth, okay? This is a precession. So as the Earth is spinning on its axis, it is going in this cone motion or this circular motion, and over time, where our true north is pointing will change, okay? And again, this does not affect the seasons. It just affects the stars that we see near the poles, so the north and the south poles, okay? So a precession takes a long time, okay? Now we're going to talk about a nutation. And a nutation actually happens every 18 years. So this is quicker, so you will live through several nutations in your lifetime, okay? So when we talk about wobbling, right, we watched our wobble video at the beginning, wobbling around the precessional axis is a nutation, okay? So what does that mean? So here, if we look at this diagram, the P stands for the precession, all right? So here's our axis, here's our Earth, the R is the rotation, all right? So the Earth is rotating on its axis, and because it's rotating, we also have the precession where it's swinging around and we're getting a change in our stars, but there's also the nutation happening. The nutation is depicted by these waving lines, okay? So when the precession happens, right, when the precession happens and the axis is swinging around, it's not doing so in a fluid, perfect circle, all right? It's wobbling back and forth, right? It's wobbling on its axis. And basically, this just results in a change in the angle, so a ½ degree one way or the other. So remember, the tilt of the axis of the Earth is 23.5. So if we're getting this wobble, at any point in time, the tilt could go to 24 degrees or 23 degrees. Okay, so it's just wobbling on its axis back and forth as the precession is also occurring. This occurs over an 18-year period and is due to the moon. Okay, so the effect that the gravity and the pull of the moon has on the Earth causes a nutation. Now, this doesn't have much of an effect. It very slightly can increase or decrease seasonal effects. So if a seasonal effect is increased, that means our winters would be colder, our summers might be warmer. Or decreases seasonal effects is kind of the opposite, but really most of the time you can't even tell anything's happening, okay? So the biggest takeaways from today is that a precession takes a really long time. It occurs over about 26,000 years, right? And that's just the movement of our axis of our Earth kind of in a like a top movement, right? So we're changing the stars that we would be able to see near the poles. So that's a precession. The nutation here, nutation is wobbling. So nutation equals wobbling. So as the precession is occurring, our axis itself is tilting kind of ½ degree in one way or the other. So rather than being at the tilt of 23.5, we could see it at 23 degrees or 24 degrees. Okay? And this is just another diagram to help you. So again, here is our Earth, the elliptic orbit it takes, and then here is our axis doing the precession as it spins, and then wobbling on its axis, going ½ degree one way or the other is going to be our nutation. And then here's another depiction. So again, the movement in the circle, so the circular movement changing the stars is the precession, and then the wobbling back and forth over an 18-year period, changing the tilt of the Earth, is a nutation. I know that's a lot, so if you guys have any questions, let me know, but this is the end of lesson 3 for today.